Hey guys, today we are starting a new unit to go along with our new 6 weeks, and we are talking about rationals, rational expressions, rational equations, and so on. Now, rational is just another word for a fraction. And some of you might be scared thinking, oh, fractions, I've never been really good at fractions. Well, we're going to take it slow, and the main thing that you need to know how to do to be able to handle polynomials inside of fractions is you need to know how to factor. So if you're not the best at factoring, I highly recommend that you go back and watch my earlier videos on factoring and do some extra practice on those, because we're going to be doing a lot of factoring here. Now, let me remind you the three main avenues we can have for factoring, and they all branch out of the first thing you must do every time when factoring, that is to look for a GCF. After you look for a GCF, if there are two terms, it's going to be one of these three. It's either going to be a difference of squares, a sum of cubes, or a difference of cubes. There's not really a whole lot of in between. If there's two terms, you're just looking for perfect squares or perfect cubes. If there are three terms, we're going to do the x and the plus sign. Remember, with the x and plus sign, we're going to do our x with a times c on top, b on bottom, and our plus sign, ax, and then our numbers. Remember, our numbers here multiply to the top and add to the bottom. This is for when we have ax squared plus bx plus c. This is our three terms. And then lastly, if there are four terms, we're going to factor by grouping, or remember, as I like to call that, double GCF. Call it whatever you like. All right, now, let's go ahead, let's break down how we can simplify these, okay? So let's go all the way down here to number 1. So number 1, I have 2x minus 8 over x squared minus 6x plus 8. Now, what we're going to do is we're going to factor the top and we're going to factor the bottom, and then we're going to cancel out anything that we can, okay? Now, just for reference, I can't just start going canceling willy-nilly. We have to have things being multiplied to be able to cancel. So for instance, I can't just cancel this x and this x from top and bottom. I have to be factored out and then see what we can cancel, okay? If there are addition and subtraction signs and we're not multiplying with parentheses, we cannot cancel them out. So let's take a look here. I'm going to take this 2x minus 8 over to the side, and I'm going to factor that first. 2x minus 8. How can we factor that? Well, first we look for a GCF, right? And my GCF for these two is going to be 2. So I'm going to pull out a 2 out of both of these. We're going to get 2 times x minus 4. Then we're going to see, can I factor that anymore? No. X minus 4 goes x squared minus 4. Then I can factor it more, but it's not. It's just x minus 4. So I'm going to build a new fraction over here, and I'm going to write that on top of it. Okay, now I also need to factor out this guy, right? Well, that is a trinomial. First step, look for a GCF. There's no GCF on my bottom, so what we're going to do is it's a trinomial, so we're going to do our x and our plus. Hopefully, you won't have to do this for every single one. In fact, on later problems, I'm just going to show you how to do it straight up. But anyways, take a look here. We're going to go a times c on top, so 8 on top, b on bottom, so we're going to have a negative 6 on bottom. Then we're going to think of two numbers that multiply to 8 but add to negative 6, and that's just too easy. It's negative 4 and negative 2. Negative 4 times negative 2 is 8, negative 4 plus negative 2 is negative 6. So those are my two numbers. We just have a 1x, because my a is 1. And then those are going to be my factors. We're going to have factors for this of x minus 4 times x minus 2. Now, I'm going to go ahead and write that down in my denominator down here. So I'm going to write x minus 4 times x minus 2. Okay, then this is where the simplifying part comes in. The only thing that you got to remember, guys, is factor the top, factor the bottom, and then we can cancel out and find our final answer by simplifying. However, last thing, before we fully simplify, let's talk about undefined values. Undefined values are, well, you cannot, I just want to talk about this. If we have 1 over x, or anything over x, x can't be 0. Why? Well, because anything divided by 0 is an undefined number. We cannot divide by 0 in mathematics. It just won't work out for us. So if we ever have a 0 down here, it won't work. So look at this. Whenever I factor these out, we get zeros. Whenever I have x minus 4, we can set x minus 4 equal to 0 and x minus 2 equal to 0. And we get two options that would change my whole bottom to a 0. So what we need to do is we need to be like, okay, we need to say what x can't be. In this case, x cannot be 4 or 2. X can't be 4 or 2. So whenever we factor it out, we got to check and see, okay, what are the zeros at the bottom? And that's my undefined values. All right, now let's cancel. Look at this. X minus 4 cancel. Because we have one on the top, one on the bottom, and we're multiplying with those parentheses. So my answer is going to be 2 over x minus 2. 2 over x minus 2, and my undefined values are 4 and 2. Let's take a look at number 2 as well. Okay, number 2. I can't factor x minus 7, can I? So I'm just going to write that as part of my fraction. But I can factor x squared minus 49. X squared minus 49 is a difference of squares. X squared is a perfect square. 49 is a perfect square. So I could change this to be written like this. A plus b times a minus b. In this case, it's going to be x plus 7. Check this out. X times x is x squared. 7 times 7 is 49. So we're going to go x plus 7 times x minus 7. So that's going to go on the bottom of my fraction. So we're going to have an x plus 7 times x minus 7 on the bottom of my fraction. Now that I have the bottom factored, we can find my undefined values. And my undefined values are going to be the opposite of what's in here. So since this one is a plus 7, we're going to have a minus 7, right? We set it equal to 0. So we get x equals negative 7. It's just the 0. It's the solution, the x-intercept, all those things we talked about earlier. So x equals negative 7 and positive 7. Those are going to be my two zeros, because if we go x minus 7 equals 0, add 7 to both sides, and we get our other answer. So there are our two answers here. Now we go back up here and be like, okay, what can I cancel out to be able to get my final answer? Well, this is a whole x minus 7. We just have x minus 7 on top. I have an x minus 7 here as well. So I can cancel that one and cancel that one. And it leaves me with an answer of 1 over x plus 7. And that's my answer. All right, let's move on and try a couple more. Take a look at number 2. We can factor the top and factor the bottom. So first off, let's factor the top. So I'm going to take the top over to the side. I'm going to factor it. So we have 10n squared minus 250. So first step, we have a GCF of 10. So I can pull out a 10, and that leaves me with n squared minus 25. And then n squared minus 25 is perfect squares. So we're going to pull that out. We're going to go 10 times, build your parentheses. Remember, it's a plus b, a minus b. So we're going to go n plus 5 times n minus 5. And those are my factors for the top. So I can go ahead and write that on top. 10 times n plus 5 times n minus 5 over the bottom. I can now factor the bottom as well. The bottom's 3n plus 15. Pull out a GCF. So we have 3 times n plus 5. Write that in underneath over here, right? And so we're going to have 3 times n plus 5 as part of my denominator. Now that I factored this denominator, we can look for what are called undefined values, right? And it's just the opposite of this. Since I have an n plus 5 there, we can go n plus 5 equals 0, and we get n cannot equal negative 5. Now, this 3 doesn't really matter, okay? That 3 doesn't affect any of my undefined values. It's only when where my x's are, or n's in this case, okay? Now, we check and see if we can simplify by reducing, and n plus 5 can cancel out with this n plus 5 on top. 10 and 3, those don't really reduce at all, so my answer is just going to be 10 times n minus 5 over 3. Can't simplify it any more past that. All right, let's take a look at number 4. So number 4, remember, we're going to be factoring the top and the bottom. So let's start with the top. To factor the top, I like to take it off to the side and factor it. So we have a negative 3n cubed plus 2n squared plus 8n. Okay, first step, look for a GCF. And in this case, remember, we don't want to have a negative in front. So we're going to factor everything out by a negative, but everything also has an n in common. So we're also going to factor everything out by an n. So I'm going to factor this out, each one by negative n. And that's going to give me out in front negative n times n squared minus 2n minus 8. Then we can factor this. It's a trinomial, so we can factor it using difference of squares. Here's my a, here's my b, here's my c. So with difference of squares, we're going to get 1n squared, not difference of squares, x and plus. I don't know why I said that. So x and plus, we're going to have a negative 8 on top, a negative 2 on bottom, so that my two numbers are going to be negative 4 and 2. So those are my two numbers. So we can write out our factors. Our factors are n minus 4 times n plus 2, and don't forget to rewrite your GCF down here of negative n. So these are our factors, and that's going to be the top of my fraction here. Negative n times n minus 4 times n plus 2. Okay, now let's factor the bottom of my fraction. So this n to the 5th minus 4n cubed. I can factor this one. And in fact, in this one, we have a GCF. We have a GCF of n cubed. So I can pull out an n cubed out into the front. Leaves me with n squared minus 4. N squared minus 4 can factor. We're going to get n cubed times its difference of squares, so n plus 2 times n minus 2. You just have to learn the difference of squares. Super easy like that, where you just factor it out and you'll get there. All right, so then we're going to have n cubed times n plus 2 over times n minus 2. And these are my denominators, so they're going to tell me what my undefined values are. So we can say, okay, what is if n cubed equals 0, or n plus 2 equals 0, or n minus 2 equals 0. And we'd be like, okay, n cubed, take the cube root of that, we just get n equals 0, n equals negative 2, n equals positive 2. Remember, these numbers are where the denominator equals 0, but we cannot have it equal 0. So these are what n cannot equal. So this is n cannot equal 0, negative 2, or positive 2. Okay, that's what n cannot equal. Those are my undefined values. Okay, now, here's the deal. We're now going to cancel out from the top and the bottom as much as we can. So in this case, this n plus 2 and this n plus 2 cancel. One of these n's and one of these n's here cancel, making n squared. So here's what we're going to have left over. We have a negative times n minus 4 on top over n squared, because one of those canceled out, times n minus 2 and then that's our answer. I can't simplify anymore. So remember, all you have to do for these, factor, then simplify. Okay, moving on to our very last problem here, number 5. So number 5, we have x cubed minus 27 on top. So we can take that out to the side and factor it first. So we have x cubed minus 27. So first step, look for a GCF. There is none. So what we're going to do is we are going to be like, okay, there's 2 terms, and one of them is cubed. Hey, this one's a difference of cubed. Because remember, 3 cubed is 27, and x cubed is x cubed. So this we can write out. Let me remind you what your formula is. It's a minus b times a squared plus ab plus b squared. Okay? Remember, just look back at the first page of this if you need help with that. All right, so we can just write it in. X minus 3 times x squared plus 3x plus 9. So that is what's going to go on top over here. We're going to have x minus 3 times x squared plus 3x plus 9. Then I'm going to factor the bottom. Now the bottom, we first are going to look for a GCF. There is no GCF. Second, we have 4 terms. So to factor out those 4 terms, we are going to need to factor by grouping. So we're going to group the first 2 together and the last 2 together. First 2 I can pull out an x squared. The last 2 I can pull out a negative 9. That gives me x plus 3 and x plus 3. So if these 2 are the same, I can pull those out to the front, get x plus 3 in front times what's left over, x squared minus 9, and then x squared minus 9 is a perfect square. So we're going to get x plus 3 times x plus 3 times x minus 3. Remember, this is a perfect square, so it's going to split into those 2. Because 3 times negative 3 is negative 9, x times x is x squared. All right, this is my denominator now. X plus 3 times x plus 3 times x minus 3. That also tells me what my undefined values are going to be. This is going to be the opposite of these, right? So it's going to be x can't equal negative 3 for this first one or positive 3 for this last one. If you have any that repeat, you only have to write it once. All right, then we see what we can cancel out up here. And in this case, I can cancel out these 2, x minus 3, x minus 3, those can cancel. And so that leaves me with just on top, here, x squared plus 3x plus 9. And on bottom, we have an x plus 3 and an x plus 3, so you can write it just like this, x plus 3 squared. All right, guys, I know these fractions with all the polynomials can be intimidating, but I promise, as long as you go and practice your factoring, you're going to do just fine. Just remember, factor the top, factor the bottom, find your undefined values, and then cancel things out. All right? Hope you have a great rest of your day. Let me know if you have any questions. Thanks, guys.